All right, let's talk about one of the most important, and let's be honest, sometimes super frustrating parts of building anything digital: speed. We're going to pull back the curtain and look at how to make your databases just fly. This is all about turning that annoying loading spinner into a snappy, seamless experience for your users. So let's get right into it.
You know the feeling, right? You're staring at that little loading spinner, just waiting and waiting, wondering, why is this app so slow? And it's so easy to blame, the app itself or maybe your Wi-Fi. But guess what? A lot of the time, the real culprit, the real bottleneck, is buried deep down inside the database. See, every single time you click a button, run a search, or even just refresh a page, you're kicking off this little journey. You're sending a request, what we call a query, deep into the database to go find some data and bring it back. And the speed of your entire application, well, it pretty much all comes down to how fast and efficient that round trip really is.
Okay, so to really get a handle on performance, we've got to follow that journey from your code all the way to your data. And it turns out every query, no matter what, goes through this very specific three-phase journey.
The whole thing is called SQL query processing. It's all handled by the Database Management System, or the DBMS for short. Think of the DBMS as, the head chef in a giant busy kitchen full of data. It's the brain of the whole operation. It takes your order, figures out the absolute best way to cook it up, and then serves you the result.
So what are these three phases? Let's stick with an analogy. How about pizza delivery? It makes perfect sense. First up is pursing. This is basically the person on the phone, checking your order. One large pepperoni. Okay, that's a valid order. One large shoot pizza. Nope, that's not going to work. That's parsing. Then comes the most important part, optimization. This is the dispatcher figuring out the single best, fastest route for the driver to take to your house. And finally, you have execution. That's the driver actually getting in the car and following that exact route to bring you your pizza. See? It sounds simple, but trust me, almost all the magic and all the performance tuning happens in that second step, optimization.
All right, so let's zoom right in on that middle step, the optimizer's secret sauce. Because if you want to unlock crazy database performance, you have to understand how a database actually thinks. So yeah, the query optimizer really is the brain. It's that super smart dispatcher from our pizza place. It's this incredibly complex piece of software, and its entire job is to look at all the possible ways to get your data. And I mean, there could be hundreds, even thousands of ways, and pick the one that's going to be the fastest. It's that simple. A smart optimizer gives you a fast app. A confused one, well, that's when you're back to staring at that loading spinner.
Okay, but here's the thing. Not all optimizers are built the same. You've got two main types. The old school one is the rule-based optimizer. This is like a dispatcher who has a rulebook that says, always take the highway. It doesn't matter if it's rush hour or if there's a huge accident blocking all lanes. The rule is a rule. Then you have the modern, much smarter one, the cost-based optimizer. This dispatcher has a live traffic map. It looks at every single possible route, estimates the cost, the time, the resources for each one, and then picks the absolute cheapest, fastest option. And yeah, this is the standard for pretty much every database you'll use today.
So that leads to a pretty obvious question, right? If our smart, cost-based optimizer is looking at a live traffic map to make its decisions, what kind of information is actually on that map?
Well, the answer is something called database statistics. This is the traffic map. It's basically metadata, which is just a fancy way of saying it's data about your data. It describes everything the optimizer needs to know: how big your tables are, what the data looks like, how it's all spread out. And this is so crucial because without good, up-to-date statistics, that super smart optimizer we were just talking about, it's flying completely blind.
So what are we talking about here? Well, take a look. Things like number of rows. This tells the optimizer if it's searching through a tiny village or a massive city of data. Then you have index sparsity, which is all about how unique the values are. Is it trying to find one of only 50 states or one of a million different email addresses? That changes everything. And maybe most important is data distribution. If the optimizer knows that, say, 90% of your customers live in one state, it can use that info to make a way smarter plan to get the data it needs. So here's the big takeaway. Keeping these database statistics current is exactly like giving our pizza dispatcher a live, up-to-the-minute traffic map. When the map is accurate, the optimizer can dodge the traffic jams and always find the fastest route. When it's not, you get those awful, slow queries that just bring your whole app to a crawl.
Okay, so we get how the optimizer works. Now for the fun part. What can we actually do about it? How can we help the optimizer help us? Well, that's where your tuning toolkit comes into play. All right, the number one most powerful tool you have for performance is the database index. And the best analogy for it is perfect. It's just like the index at the back of a book. Think about it. Without an index, if you wanted to find a specific topic, you'd have to read the entire book page by page. That's what a database does without an index. It's called a full table scan. It's slow, it's painful. But with an index, you just flip to the back, find your topic, and go straight to the right page. It's a game-changing shortcut.
So naturally, you're probably thinking, okay, indexes are amazing. They're like magic. Why don't I just put an index on every single column in my entire database? It's a great question, and one that everyone asks.
And the answer is because there's no such thing as a free lunch, especially in databases. Indexes make reading data super fast, but they have a cost when you write data. Every time you do an insert, an update, or a delete, the database has to update not just the table, but also every single index on that table. Sticking with the book analogy, it's like having to redo the index every time you add or change a sentence in your book. That extra work, that overhead, can really slow down your write operations. So, the real art here is being smart and strategic about your indexes. Here are some good rules of thumb. For sure, you're going to want to index your primary and foreign keys. That's a given. You'll also want to index any columns you're using a lot in where clauses for filtering or in order by clauses for sorting. But here's a big one. You generally want to avoid indexing columns that don't have many unique values. Think of like a gender column or a status column that only has 2 or 3 options. An index there just isn't very helpful, but you still have to pay that cost to maintain it. It's all about finding that perfect balance.
So the next time you're looking at a slow app, I want you to see more than just a loading bar. I want you to picture that query's journey and ask yourself 2 things. 1, is my database's traffic map up to date? And 2, have I built the right shortcuts, the right indexes for it? Because at the end of the day, amazing performance isn't magic. It isn't about just throwing more expensive hardware at the problem. It's about smart design. It's about understanding how your database thinks and working with it. Thanks for tuning in.